Okay, let's start the class. So good afternoon guys, welcome to Chandu Biology classes. I hope you are doing well and you have revised the last topic of electrostatics which we have completed, right? And we'll continue with the topic where we have left. Okay, so in last class we have left up to, we have completed up to the potential, I guess. Yes, so we have completed up to this topic, that is relation between electric field intensity and the potential. So this is the topic which we have completed in last class. So let us see the problems related to these questions in this class, and we'll continue with electric flux, Gauss law and capacitance, and we'll see some of the PYQs of IIT JAM. Okay, so now find the potential difference between point A and B. This is the thing, point A and B in the uniform field. So this is the main point of this question, like a uniform field. Okay, so here they have given that the electric field is E naught and point A is 1, 1 and point B is 5, 5, right? So this is the thing. So potential, right? So potential in the sense, first we need to find what is the distance between them, right? What is the distance between them? So if I take this diagram here in the graph point of view, so this is my diagram, like this is the line, okay, and when I talk, this is 1, 1 and this one is 5 and this is 5 again. So if this distance is 5 minus 1, that is 4, and this distance is also, it's 4. So if I want to find AB, no, it is hypotenuse. So AB square will be equals to 4 square plus 4 square, which is nothing but 16 plus 16. So under root of 32, right? No, under root of 32. So let's take a LCM point of view, that 32 to 16 and this to 8, 2 again 4, 2, 2. So 2 and 2. So what happens here? It is 1 times and 2 times 2 square. Okay. So 2 power 5, no, 2 power 5. So we can take it as root over 2 power 4 or 2 square power 2 into 2. Is that fine? So in this, what happens is 2 and 2 will and root and will get cancelled. So finally we will get 4 root 2 is the value of AB. Okay. Now the potential they are asking, right? So potential in the sense V is equals to, in terms of electric field they are asking. Electric field is given as E naught. So when we see the formula here, it is E is equals to dV by R, no. So it is dV by R in the sense E is equals to V by R. So V will be equals to, what is the electric field here? E naught, and R value is 4 root 2. So 4 root 2. So this is the answer for this given question. So the potential in this question is 4 root 2 E naught. In terms of electric field, that is E naught. Okay, you can take a note of this and we can go for the next question. Done? Okay. So the next question is, if a point charge moves around in a circle about a charge q, then work done by the charge will be. So when we talk about this question, no, let me take a diagram of the thing. So this is my circle, right? So when we talk about any circular path, if we talk about any circular path work done, right, work done, right. So simple diagram I will draw here. So when we talk about the force, it is centripetal force towards the center F, and the direction of the particle, for example I will take this is the direction, so it will be in this direction. So if we see the angle between the force and the displacement, right, it is 90 degree. So whenever we talk about a circular path, no, a circle and the work done, okay, so work done by the circle will be always equals to 0. So for this charge also the work done will be 0, right. So circular path work done is always 0. This is the answer for this question. Done. So the next question is, consider a non-spherical conductor, yeah, shown in the given figure. Let me draw the figure here. So this is the diagram. So it's a non-spherical, okay, it's not a spherical, it's a not a spherical, okay, which is the given a certain amount of charge, the charge distribution itself on the surface such that the charge density sigma 1, 2, 3 at a region. So let me take the region 1 and this is 2. So this both are 3. Okay. So they have given charge densities, right? Charge densities. So this is sigma 1, this is sigma 3 and this is sigma 2. So we need to find which region as the higher, right. So when we talk about the charge density, we need to talk about the radius of curvature. Radius of curvature. So when we talk about charge density, no, charge density is inversely proportional to radius of curvature. Radius of curvature. So when radius of curvature is more, charge density will be less, right. So radius of curvature is less means charge density will be more. So the order will be, can we write like this, sigma 2 greater than sigma 1 greater than sigma 3. This is the order in the descending order. And when we talk about ascending order, no, like obviously it will be in the reverse manner. So higher, like less, this one will be less and this one will be less and this one will be, this one will be more and this will be more, right, no, right. This is the answer for this question. Okay. So whatever the questions which we are seeing here, like everything is different kind of questions which they might ask in the IIT JAM, okay. At last, once we have completed this chapter, no, we will see the PYQs, okay. So the electric potential at a point XYZ given by V is equals to, okay, V is equals to minus 5x square plus 3y plus 15z cube. The electric field E at that point is, so we know that E is equals to dV by dr, right, dV by dr. So this is the terms we know, like this is the formula we know, D is equals to dV by dr. So when we talk about this question, right, it is in terms of x, y and z. So we can do partial differentiation. E is equals to dou v by dou x, E is equals to dou v by dou y and E is equals to dou v by dou z. Okay. So now if you see here, we need to differentiate partially with respect to only x values. So the remaining values, what happens, 0 and 0 will become, right, no. So this is minus 10x plus 0 which is nothing but minus 10x. So when we talk about y, we need to differentiate only y, the remaining two terms will become 0 again. So will be equals to 0 plus 3 plus 0. So finally it will be 3. So final one will be 0 plus 0 plus, so 15 3s are 45 z square. So final what we should do is this Ex, Ey and Ez. So answer will be E is equals to Ex plus Ey plus Ez. So which is nothing but minus 10x plus 3 plus 45 z square. 45 z square. So this is the electric field at this point V is equals to, at this point y x y z at potential minus 5x square plus 3x, so 3y plus 15z cube. Okay, this is the answer. Done? Can we go for the next one? Okay. So the next topic is electric flux. So here electric, we know like electric field, electric charge, everything. What is the meaning of flux? So flux is nothing but like it's a measure of how much electric field passes through a given surface. Okay. Suppose if we take electric field lines are going like uniform electric field lines, okay. I am talking about uniform electric field lines. Here I am taking a circle of radius 2 centimeter and I am taking one more circle of radius 10 centimeter. So in which we can expect more number of fields is passing. We can say that 10 centimeter as the more electric field passes, right? No, so it has more compared to 2 centimeter, right? So why? Because this has bigger area compared to this 2 centimeter, right? So one more thing we can understand here, if field lines are equal for the both the cases and the area is different, the flux also will be different, right? So if field lines are less, the flux which passes through the surface area also will become less. So obviously the electric flux depends upon electric field lines and the area of the surface also, and in which angle we are keeping the surface also, it's important, okay. So the thing is, electric flux is a measure of how much electric field passes through a given surface at given angle also, okay. Let me write that also, at given angle, right. So electric flux tells us how many electric field lines crosses the surface. So more electric field line, more flux, fewer electric field lines, less flux, okay. So this depends upon the electric field lines, area and angle. These three are important for the flux point of view. So the formula will be, flux is denoted by the letter phi. So phi is directly proportional to E S cos theta. So I can say phi is equals to E dot S, okay, E dot S. So phi is equals to E dot A or E dot S. S is nothing but the surface area. Here A is also nothing but area only, okay. EA cos theta or ES cos theta, both are same. So electric field and area of the surface, and theta is the angle between the electric field and area vector. So when we talk about the resultant, like electric flux is a scalar property because we are using a dot product, right. When we are using a cross product, we will get a resultant as vector, but here we are getting a resultant as a scalar. So electric flux is a scalar property. Lalit, good evening. Okay, this is about electric flux and the formula. So what does electric flux depends upon? So it depends upon electric field, surface area and the angle between them. So stronger electric field, more flux, larger area, more flux, and vice versa of that, like lesser electric field, less flux, area is less, flux is less, and maximum flux when field perpendicular, right, perpendicular, and zero flux when field is parallel, okay. So electric flux through a closed surface. So this is the important thing. So this is Gauss law, will say Gauss law, okay. So closed surface completely enclose the volume. So for example, for sphere, cube, cylinder, etc. Okay. So it is phi is equals to Q enclosed or Q in, we can say. So Q in by epsilon naught, right. So flux depends only on the enclosed charge, not on the shape of the surface, size of the surface or position of charge inside. Suppose let me take a surface here. So if I am considering a positive charge Q here, okay, obviously this positive charge have electric field lines or any charge, okay, electric field lines will be there. So now I am shaking this surface and finally I am getting this charge in this place. Will the electric flux, electric field line will change? No. So it doesn't change. But one more thing, if I talk about some other charge I am bringing here, for example, let me take plus Q, one more thing. Here the field lines will change here? No. But the direction of field line will change. The direction of field line changes. Field line changes, but it doesn't affect. That's the thing. Like flux depends only on the enclosed charge. Enclosed charge is the important thing. Like the charge which we are considering out, it doesn't matter. For example, if we talk about a surface is there, this is Q1 minus Q3 plus Q5 and Q2 is there minus Q4 is there. So what is the flux in this surface they are asking? So flux in this surface in the sense, so it will be phi is equals to Q in by epsilon naught, right? We know that epsilon naught is nothing but permittivity, depends upon the medium. So Q in, what are the Q in present here? Q1 minus Q3 plus Q5. So Q1 minus Q3 plus Q5 divided by epsilon naught. So we are not considering this Q2 and this Q4 also. Why? Because we are talking about the enclosed surface. Enclosed surface is the important point over here. So we are not talking about the Q2 and Q4 charges. It doesn't affect the flux in the enclosed surface. Okay. So general properties of conductors. Now we are coming to the conductor's point of view. Okay. We have completed now the electrostatics potentials. Okay. Now capacitance is there. So before starting capacitor, we need to know about some properties of conductors. Okay. So general properties of conductor in the sense, a conductor has large number of free electron. So large number of free electron in the sense, it allows the flow of current. So free electron can move easily inside the material. Example, copper, aluminum, silver are the example of the conductor, and some more. We have taken only few things. Okay. So in electrostatic equilibrium, charge do not move. What is the meaning of that? Electrostatic itself says that static, rest, no, rest. So charge do not move, conductor remains stable. Okay, this is the point. So properties of conductor regarding electric field. So electric field inside a conductor is 0. So inside it will be 0. And reason, if electric field existed inside, free electrons would move. And contradiction to equilibrium. So we are talking about equilibrium condition and we are talking about the electrostatic, right? We are talking about electrostatic things, and that's why the electric field inside a conductor is 0. Okay. So second point, excess charge resides only on the surface. So when we talk about the surface or any system, no, and if this system is a conductor, every charge particle will be present. Present at the surface, only. Okay, no excess charge inside the conductor, so there won't be any excess charge inside the conductor. All extra charge spread over the outer surface. So electric field is normal to the surface. So electric field is always normal to the surface, and electric field never makes an angle with conductor surface, right? So tangential component of electric field is always 0. So these are the properties, and the fourth property is electric field just outside the conductor is sigma by epsilon naught. Sigma by epsilon naught, where sigma is the surface charge density. So we have solved a problem based on this, which is sigma is inversely proportional to R, right? So how we have got that is nothing but when we talk about electric field, E is equals to F by Q. We know that F is nothing but K Q1 Q2 by R square, right? So from this, E is directly proportional to sigma, and sigma is inversely proportional to the radius, right? Now, so charge density is maximum at the sharp edges. So charge density maximum at the sharp edges. So this is the question we have seen here. So sharp edges, no, so it is maximum at sharp edges and less, and it is more or less here. Okay. So next point is properties of conductor regarding electric potential. So previous thing is we have talked about electric field and now we are talking about electric potential. So both are different. Okay. So potential is same everywhere inside a conductor. So inside a conductor constant potential, no potential difference inside. So which is V inside will be always like potential inside will be always constant. So entire conductor is an equipotential body. Equipotential is nothing but the same potential throughout the surface, the same point which we are repeating here. Okay. So surface and interior have same potential and moving charges inside requires no work. So the charge which is moving inside doesn't require any work. So potential of a conductor equal surface potential. So when we talk about a potential of a conductor which is equal to the potential of the surface. So when I talk about any system, so at the surface the potential will be equal throughout the conductor. So no work done is moving charge on the surface. So since potential is same everywhere on the surface, right? So it is 0. Potential will be 0. So this is about the properties of conductor which is based on electric potential. Done. So I have given a simple tabular column which is easy to analyze. So quantities and inside the conductors. So quantities are like electric field, electric potential, charge distribution and work done. So electric field will be 0, okay, 0 it is, electric potential is constant and charge distribution only on the surface, it is not inside, okay, and work done will be 0, right. So next one we are talking about the capacitance. So capacitance formula is C is equals to Q by V. What is Q and what is V is nothing but Q is the charge and V is the potential difference. And what is the unit of capacitance is, it is farad. And when we talk about the combinations, so when we talk about a resistance, a resistor, okay, whatever it is, like when we talk about a series or parallel, we have some formulas for that. So similarly for capacitor in series and capacitor in parallel also have some formula. So both are like inverse matter, okay. So when R series they are asking R1 plus R2 plus up to goes on, and 1 by R parallel which is nothing but 1 by R1 plus 1 by R2 plus up to infinity, like how many resistors we are taking, fine. So if we talk about capacitor in series which will be similar to resistance in parallel, when we talk about capacitor in parallel which is similar to resistance in series, okay. So if we see here, so capacitor in series we have considered 3 capacitors, so C1, C2, C3. So capacitors will be like a parallel plates will be there, okay. So we have taken like this. So this is my C1 and this is my C2 and this is my C3. So if they are asking what is the equivalent capacitance, so I need to do 1 by C equivalent will be equals to 1 by C1 plus 1 by C2 plus 1 by C3. So here the properties will be same charge on all capacitors, charge will be same on the capacitors and total voltage will be sum of voltage, like voltage I need to add it, V1 plus V2 plus V3, and capacitance equivalent is less than the smallest c, it is always equivalent, like these equivalent capacitance will be less. So capacitor in parallel will be C1 plus C2 plus C3 and here voltage will be same, here charge will be same, here voltage will be same. So here we need to do V is equals to V1 plus V2 plus V3, where here we need to do Q is equals to Q1 plus Q2 plus Q3, okay, and equivalent capacitor is greater than the normal C which we have taken here, okay. This is about the combination of capacitor when it is in series or when it is in parallel. So now parallel plate capacitor without dielectric. So without dielectric in the sense we are not keeping any material in between the plates. So the formula will be C is equals to epsilon naught A by D. What is A is nothing but A is the area of the each plate and D is the distance between the plate, okay. So with the dielectric is nothing but K epsilon naught by D. So K is the dielectric constant which is relative permittivity we will say, okay. You can take a note of this and we can go for the next slide. Done? Okay. So the next one is, yeah. So energy stored in the capacitor, it is one formula in terms of CV, it is U is equals to of CV square. So other useful formulas like Q square by 2C are of QV. Okay, three formulas are there. One is of CV square, second one is Q square by 2C, and another one is of QV. Okay, these are the three formula which we can use in the energy stored in capacitor. And energy density is nothing but U is equals to 1 by 2 epsilon naught E square, or else we can say with the dielectric it is K epsilon naught E square, right. So next one, force on dielectric slab, it is of V square into dC by dx. And when we talk about the arrangements, no, yes, series charge is same and voltage is divided, and parallel charge will be divided and voltage will be same. This is about the capacitance. Yeah. So effect of dielectric on capacitors. So when battery connected, no, so what happens is capacitance increases K times and the charge also increases and energy also increases. But when we disconnect the battery, no, what happens is capacitance increases but charge decreases, energy decreases and voltage also decreases. Why? Because capacitance is nothing but it's a storage of energy, no, like obviously when I remove also the energy will be there, like the capacitance also capacitance will be increased but voltage and energy will be decreased, right. Why energy decreases means we are, after removing that, we are using that energy. Okay. Okay, so up to this the topic has been completed, and we will see some PYQs of this lesson, and if we complete this PYQs, the lesson has been completed, right. So here is the first PYQ. If a conducting sphere of a radius r is given a charge q, which one of the following graph represent the variation of potential as function of distance r from the center of the sphere. So okay, you can take a look of this question and we will discuss the question. So there you can take a 1 minute of time to look of this question, and you can give an answer which is the correct options. Okay, can we see the answer now? Okay, so when we talk about now electric field which is inside, no, it will be 0 first thing, and when we talk about the potential, no, so V in will be constant, it doesn't change. Whereas when we talk about electric field out, it is 1 by r square, and when we talk about potential, no, so it is 1 by r. So where we can find it is like potential, initially potential will be constant, so either it is option 4 or option 1, so I can eliminate option 2 and option 3 easily, right, and it is inversely proportional, right. Inversely proportional means option 4 will not be give the correct option, so option 1 is the best option, right now. So first it is constant and then it will be decreased, right. So this is the option, correct option for the first question. So second question, this is the question. So current I1 I2 flow in opposite direction, okay. Two long coaxial tube as shown in the given figure. So the magnetic field at any point in the annular region depends on. So which one is the correct option? So you can take a look of this question. I'll give a 1 minute time and you can give the answer. So we'll discuss the answer. Done? Can we see the answer for this question? So if we talk about the magnetic field, right, it will be integral of B dot dl, okay. So which is equals to B into what is the thing, 2 pi r, okay, the circumference. So 2 pi r, and when we talk about the current, no, it is mu naught I enclosed, okay, enclosed. So what is the current which is enclosed here? It is only I1. So which is the option? I1 only, okay. Suppose if they are asking I2 here, okay, so I2 in the opposite direction, obviously I need to consider I2 also, but I2 is outside. But the thing is, the current which is enclosed in the surface only we should consider. So enclosed current is only I1, that is not I2, okay. So this is about the second question. So like in IIT JAM, no point of view, they won't ask detailed question, like they will ask a theoretical way of question, okay. Mostly they have asked only theoretical way of question, and sometimes they can ask a question based on the combination of resistance or capacitance of that, okay, and we'll see that questions also. So the next one is resistance R, capacitance C and inductance L are connected in series in the circuit, okay. So they have connected in the series in the circuit. So keeping the resonant frequency same, the quality factor Q can be doubled if, what is the correct option? If L is increased to 2L or C is decreased to C by 2. C is increased to 2C or L is decreased to L by 2. And option 3 is L is increased to 4L and C is decreased to C by 4. So C is increased to 4C and L is decreased to L by 4. So these are the 4 options. You can take a look of this question for 1 minute and you can give the answer for this question. Done? See, I will give you the formula also. Omega naught will be equals to 1 by root over LC and Q is equals to omega naught L by R. Okay, so this is a frequency, resonance frequency, and this is quality factor. Okay, so let me give this is a resonance frequency and this is quality factor. Okay, so you can use this formula and you can get the answer. Okay, we'll see. Yes, it's option 1 is the correct answer, right. So because when we talk about Q, quality factor is directly proportional to L, right? No, so if we see L is increased by 2 times, no, like C will be decreased by 2 times, that's the thing. Okay, this is the answer for the first question. For the third question, okay. So the next question is 2 resistors 2 ohm and 4 ohms are combined in parallel. Combined in parallel they are given. Okay, in this combination is connected to a battery 16 volt, the maximum current that can be drawn from the batteries. So see the formula what they have given, I mean see the resistor they have given, it is R1 is equals to 2 ohm and R2 is equals to 4 ohm. So when we talk about equivalent resistance, no, so 1 by R parallel will be equals to 1 by R1 plus 1 by R2. So it is 1 by 2 plus 1 by 4. So cross multiply this, 4 plus 2 divided by 4 into 2. So which is 1 by R parallel. So take in to reverse manner. So R parallel will be equals to 8 by, this is 6, 4 by 3. So this is my equivalent resistance, right? Now equivalent resistance, final resistance. So they have given that they are combined in this manner. So this has been connected to a battery, right? 2 ohm and this is 4 ohm and this is how much? 16 volt. Now we know the formula V is equals to IR. So I will be equals to V by R, no. So what is V? It is 16 and what is R? 4 by 3. Take this 3 to the numerator. So it is 16 into 3 by 4, 1 times and this 4 times, answer is 12 ampere is the answer. Okay, this about this question, right. So next question is, a metallic wire of electrical resistance 40 ohm is bent in the form of square loop. There is a metallic wire, okay, there is a metallic wire of electrical resistance of 40 ohm. Now they have bent in a form of square, So the resistance between the any two diagonal, they are asking any two diagonal, either I can take like this or like this. Okay, so if I talk about the bent, no, so each side will be 10 ohms, right? 10 ohm, 10 ohm, and this is 10 ohm, and this is 10 ohm. So any two diagonal in the sense, can I take this diagonal now? For example, if this two diagonal means, I mean this one diagonal, okay, this diagonal. So this is in series and this is in series and these two are in parallel. I will write here. So first, second, and this is third, and this is fourth. So 10 ohm, 10 ohm, 10, 10. Correct now? Any one diagonal I have taken, right now. This how it will be looking like. So 10 and 10, it will be 20 ohm. 20 ohm series, no, R1, R series will be equals to R1 plus R2, 1 by R parallel will be equals to 1 by R1 plus 1 by R2. Now this is 20 ohm and this is again 20 ohm. So what is the resultant here? 1 by R parallel will be equals to 1 by 20 plus 1 by 20. So if I cross multiply 20 into 20 divide by 20 plus 20. So R parallel will be equals to 40 divided by 20 into 20. So this is 2 times and this is 1 time, right? Okay, let me write here. Here no place is there, no. So 1 by R parallel will be equals to, what is this? 1 by 20 plus 1 by 20, and this is 20 plus 20 divided by, and this is 20 into 20, right now. So I will take this numerator, R parallel will be equals to So 20 into 20 divided by 40, 1 0 1 0 1 times, and this is 2 times, and 1 times, and this is 10 times. So final answer is 10 ohm. So 10 ohm is the resistance. That's it, answer. 10 is the answer. I get it cleared, right? So I'll give one more question over here. This an electron is released with a speed of 1600 meter per square in xy plane. There is a uniform magnetic field. So let me take a speed v is equals to 1600 meter per second, and uniform magnetic field B is equals to 1 into 10 power minus 3 Tesla. Along the z direction, the radius of circular path, I need to find the radius of circular path, right? Mass of the electron, it is 9 into 10 power minus 31 kg, and charge of electron Q is equals to 1.6 into 10 power minus 19, right? No? So what is the answer for this question? They are asking radius, right? So can you give answer for this question? You can take a 1 minute time for this, and you can give answer for this question. So with this, we will end up this session after completing this. Okay, you can take a time of 1 minute, and you can give the answer for this question. Done? Can we see the answer? So it is perpendicular, they have given, no? So uniform magnetic field, say like x, y and z. So obviously we can say that where is that z? It is yeah, along the z direction. So it is perpendicular, obviously. So we can take the formula, that is R is equals to mv by R is equals to mv by bq, mv by bq. So when we talk about this, what is m? It is 9 into 10 power minus 31, and what is v? It is 1600, like 16 into 10 power 2 divided by b is 1 into 10 power minus 3, and it is 1.6 into 10 power minus 19. Okay, so let me take the values which are like 9 into 10 power 16 divided by 1.6 one side, and remaining value 10 power minus 31 into, so this one is going up and this also is going up. So minus 3 and minus 19 means minus 22 means minus, so it will be plus 22. 22 into 10 power 2. Fine. And this I can take it as 16, and I'll add one more 0 here, 3. So now 1 times and 1 times, so 9 into 10 power 31 minus 10 power, sorry, 10 power minus 31, 10 power 25, it is 10 power minus 6. So it is 9 micrometer. That's the answer. Okay, this is the answer. So options are given 10, 10, 10, 10. Okay, we can take approximately 10 micrometer. So option B is the answer for this question. Okay, so with this we'll end up this session of the electrostatics and potential and capacitance. I hope it's cleared, right? So we have solved some IIT JAM questions also. Okay. Okay guys, we'll meet in the next topic, right? So the next topic will be ray optics, dual nature of matter, atoms and nuclei. Okay, thank you guys.